So welcome to another video for the Homelab series, and today we're going to talk about storage. And if you've seen my other videos, you probably know that I like storage and have a lot of it. And in this particular video, we're going to focus on building a network-attached storage device. And I think in the Homelab, there are really two big categories of the kind of network-attached storage you're going to build. The first is maybe an array that is for a Proxmox server or a VM server. And so it's going to run VMs and lots of random IOPS. And a demand for pretty high performance and not necessarily that large of an array. And then the second kind of network attached storage would be an array for long-term storage of stuff that you have. It could be your video, audio, emails, files you've collected, data you have, all kinds of sort of large collection items. And we're going to focus on that second type, the sort of large array of stuff that basically you don't want to lose, but you also want to have in a usable fashion. So your Plex server might stream video from this array, and you may have other devices in your house back up to this array as an example. And so we're going to build sort of a medium size array, maybe somewhere between 100 and 200 terabytes, which is sort of small on the big array size. If you're building an array that's more than maybe 700 or 800 terabytes, when you get up to a petabyte, there are probably some different considerations of how you build that array, especially how you can make the array reliable and back it up. But in this case, we're going to go a little smaller and focus between the 100 and 200 terabyte range. I think with any array, your goal is to build the array and have it be fast enough for the particular use cases you have, and also not lose the data that's on it. And so we'll walk through some different options about what types of things you can do for redundancy. But regardless of how you build the array, and regardless of what RAID level you use or how it's configured, you should always assume that you can lose a particular array because of a problem, and you should have a backup of that data somewhere else. And it could be you back it up to LTO tape, or even just to hard drives you stick in a safe somewhere. But a backup is the really only alternative to give you real reliability of not losing data. But within that constraint, we can do everything we can to make an array as reliable as possible. And so we're going to focus on that range. I happen to have a server that I decommissioned just recently that has 14 terabyte drives in it that I'm retiring. So we're going to use those drives to build an array. And so we'll start by looking at sort of the hardware side of it. So you have 16 disks that you want to use to build an array. We'll probably throw in a few more disks. You're going to need a boot disk for the machine, and maybe you have a disk or two to use for both the log and caching. And so those are some extra variables. So maybe it's more like 18 or 19 disks that you need to do something with. And so the question is, what do you build or buy so you can put all those disks together and make a nice network-attached storage device? And so we're going to head over to the lab and take a look at sort of three different physical approaches to how you can take all those hard drives and integrate them together. And then we'll start walking through some of the unique properties of things like SAS expanders and how SATA over SAS works in the case of expanders and some of the limitations of those kinds of architecture. So let's head over to the lab and take a look at some physical stuff first. So let's talk about storage. So we're going to think about building a network-attached storage array. And so there are a number of options of how you can choose to physically build this. So one option, which is a good one, is to buy an enterprise server, sort of a retired enterprise server. And this is a Supermicro one that has 36 drive bays. And of course, there's a motherboard in here with 2 Xeon CPUs, and I think the server has a half a terabyte of RAM. And these servers are relatively inexpensive because they're a couple generations old. These are 6 gig SAS SATA ports, so still pretty reasonable to use with modern drives. And it's all in one box. The motherboard itself has a SAS controller plus a network controller on it. And so all you really need to do is add the appropriate drives, and you can build yourself a nice NAS array, easy to install Unix on or Linux on, and then run ZFS. And they're readily available. Lots of them, Dell ones, Supermicro, a number of different brands of these kind of servers. And you can, if you're building it for a just storage array, you really don't need that many cores. So sometimes the low core count ones are really inexpensive, even with lots of RAM. And so that's an easy option. So a second option, instead of having a server with all the disks in the same box, is to buy, let's say, a little 1U server. It could be a Dell 420 or a Dell 430 or a Gigabyte or any one of the 1U server platforms. And in that platform, put in a SAS HBA card and instead connect it to a JBOD. And so these are JBOD boxes, which are just boxes that hold disks, and they have a SAS backplane in them. And that SAS backplane is connected to a connector on the back of the unit. And then there's dual power supplies, and then a little on-off switch and some LEDs. Inside this actual box is a little tiny, I have one here. This is the little tiny motherboard that's in those super micro boxes, and all it is, it takes the power supply and turns it on and off, and does a few of the SM bus stuff for fan control. So relatively simple and relatively reliable. And you can buy JBODs from tons of different people. There's Dell ones, EMC ones, the Supermicro, a bunch of generic ones. And almost all of them are very similar in that you have a bunch of disks, the power supply, and then the SAS expander with the SAS output on the back. So let's take a look at the back of one of these. And so you can see that on the back of these chassis, there's two SAS ports. And the reason there's two is because one is an input, one is an output. So there's only one SAS controller in there effectively, but the two connectors allowed you to daisy chain from the host controller in here and then out of here into either another array or say a tape drive or any other SAS device. But it's important to note that that means that all 16 drives in this chassis ends up going over this one 4-lane SAS connector. And so there are some bandwidth limitations there that you want to consider. And we'll dig into that in a little bit more detail here in a second. So that's kind of a second option, which is to use a disk array. So a third option is sort of the roll your own server, which is you can buy a server chassis box. This is a really old Norco one from at least 10 or 12 years ago. But there's a number of companies making them now, very similar, where it's just a case with support for either 16 or 20 hard drives and very, very, very simple SAS backplanes. In fact, I have one of these that we're taking apart right now. Let's go take a quick look at that. So I have one of these build-it-yourself servers. This is one that I'm retiring that's probably at least 10 years old. It's also in a Norco case with a little removable drive bays. And what's interesting about these old ones is that the backplane is really just almost like a little edge PCB that takes the 4 drive SATA lanes and puts them all into one SF8087 connector, which you then connect to an adapter. And so these are old 9207 8i LSI cards, which is a really great card from probably 12 years ago that has 2 SF8087 connectors on them. So a total of 8 lanes of 6 gigabit SATA. And those are PCI Express 3 8-lane cards, I think. So, and PCI Express 3 would be 8 gigabit per second. So it has plenty of bandwidth to the CPU from each of the 2 connectors. And then in this case, I also have, because there's 20 drives total and that's only 16, I have the other 4 using a little breakout cable that uses the onboard SATA ports. And so this is entirely SATA, not SAS. But it is a pretty inexpensive way to do it. You get to pick the CPU. This is a really old Intel 5th gen board, from what I can tell. And I built this box, like I said, maybe 10 years ago, and I just turned it off a week or 2 ago, and it's been flawless. Not a single problem, other than a few dead hard drives. The PC itself has been working great the entire time. And of course, you get to pick the PC and the power supply. I think I have a couple SSDs that I added later that are cache drives. Again, just normal SATA connectors. And so this method is sort of a inexpensive way to do it if you can find one of these chassis and you can pick your motherboard and then whatever RAM you want. The downside is it's not an enterprise case, so there's no IPMI and it's not dual power supply. And the drive connectors, sleds are not quite as good. And most importantly, this doesn't do both SAS and SATA. Those are only SATA connectors. And so you kind of miss the opportunity for some of the cool SAS stuff. And so it certainly is a third option of how to build. And so now let's talk a little bit more in detail about the SAS SATA interconnect, and in particular how it works with SAS expanders, because there are a couple of interesting technical tidbits there. So let's get to that. All right, we're going to start off by talking about JBOD and SAS. And in particular, so let's start with, you're going to have some Box O disks, a JBOD. And this JBOD may have, let's say that it has 16 hard disks. here in the front. And on the backside, it has this SAS output. And this is 4 channels of 6 gigabits per second. And so if you were to see one of these on eBay, it would generally be called a SAS 2 JBOD. SAS 2 is the 6 gigabit standard. There also is SAS 3, which is 12 gigabit. And there actually is a SAS 4 and SAS 5, but you're probably not going to see those in cheap JBODs right now. The really cheap ones are going to be either SAS 2 or SAS 3. A lot of the cheap ones right now are SAS 2. And so many of them of this size with 16 disks are going to have this single 4-lane SAS connector on the back. It'll often be an SF. That could be the 8088, or it could be the high-density one. Usually the SAS 3 ones use the little high-density one, which I forgot the number for, but it's a small square connector with like 2 little blades in it. And so the idea is that you take your main machine, that's going to be the one in charge of this whole thing, and in here you install a SAS controller card, or it could be on the motherboard, as long as it has an external port. And then you're going to run a cable from the port there to the port over here. And this cable can be a variety of lengths because this is SAS. I think it can be up to, I think, 7 meters, if I remember correctly. So pretty far, actually. You can make a pretty good length of cables. And I also mentioned before that most of these arrays are going to have a second connector intended so you can daisy chain to another JPod if you want, or to a tape drive or something else. And so we'll start with perhaps the most important thing, which is that the channel between here and the controller here, so this is, in the case of SAS 2, has 4 lanes of the 6 gigabit per second traffic. And the actual encoding scheme used for this, so this is effectively, this is a SAS cable, and the protocol running over this is in fact a SAS protocol. And that becomes a little bit important because in many cases, these drive arrays will support plug-in hard drives, and the drives can be either SAS or they also can be SATA. And so it's worth mentioning a little bit about that. So if you look at the back of a hard drive, the connector on the back, it has a little connector like this. And the SATA drives end up having a space such that you can plug a SATA drive into a SAS backplane, but not the reverse. And so SAS is sort of a bigger set of things than the SATA. And so you can take a SATA drive and plug it into the connectors in here, which are SAS connectors. And there's a couple of interesting things about that. The first is that the actual pinouts of the signal part for both SAS and SATA, it's the same. It ends up having 2 TX lines and 2 RX lines. They're differential pairs. And the actual encoding on the line, so the lower level physical encoding, is the same for SAS as it is for SATA. In other words, if you were to put an oscilloscope, they would look very similar. They both use a 10B, 8B encoding scheme where it takes 10 bits of line space to encode 8 bits of data. And so if you were to put a little probe on one of these lines and it was running either SATA or SAS, it would look pretty similar on an oscilloscope, with one interesting difference, which is that the SAS standard has the voltages, so the differential voltage between the pins is higher for SAS, so it's this far, versus SATA, it's a little narrower. And that was done in part so that SAS cables can be longer and you can go farther distances. So if this were a cable running just the pure SATA signals, it can't go quite as far. And so the SAS standard allows you to have disk arrays that are chained. And that's somewhat important because if you end up doing a bunch of JBODs, there is some virtual distance inside the box as well from one connector to the next. And so you wouldn't want that total length to exceed the SAS length. So having higher voltages makes a difference. Now that poses some really interesting problems because even though the encoding is the same, the actual protocol sent is very different between SATA and SAS. And so the way these chassis work is that inside of them, they have these little chips called SAS expanders. And in most cases, they'll nowadays have just one of them. In the old days, there were some original ones that end up having 4 of them, one for each lane. A modern one will have one chip that has all 4 lanes coming in from the SAS connector from the outside world, and then has outgoing 16 sets of lanes to go to the hard drives. And what's great about the SATA expanders or the SAS expanders is that they generally allow the drives that plug in to be either SAS or SATA, and they allow them to be effectively intermixed. Now, if you read the internet and you read on Reddit, you'll see a lot of threads talking about don't mix SATA and SAS in the same chassis or on the same lanes for an expander. And the reason for that is that some of the very early SAS expanders were perhaps a little buggy with that particular configuration. But it's important to understand that the SAS2 standard fully defines that the drives can be individually be SAS or SATA. And so in almost all of the modern chassis, you can in fact plug in SAS and SATA drives effectively at will. Now, there are some potential problems you can have when you mix them related to performance, and we'll talk about that in a second here. But at the core level, it fundamentally should work. The SAS architecture is relatively straightforward in defining how things interact with both SAS and SATA. And one of those is that when this chip boots up, it's going to go out and look at all 16 drives. And its job is to figure out, well, one is if there's a drive there, and two, what kind of drive it is. And most of the SATA expanders will initially send out, there's a thing called an out-of-band sequence, which is a way that over this TX-RX pair, you can kind of probe a drive and say, hey, are you there? And what are you? And these expanders will start by probing at the lower voltage and looking for the presence of a SATA disk. And if the SATA disk responds, and it knows, hey, this is a SATA disk, and it remembers that. And then from that point on, that particular connection going from the expander to this particular SATA drive, it will then run the SATA voltages and also the SATA protocol. So it'll negotiate with the drive, determine the size of the drive, and all the other things that it can pull over SATA, and be able to pass that information back up through SAS to the host over here. If it fails at that, it'll then typically try to do a SAS negotiation, which it will do at the higher voltage, and then look for a SAS drive to respond. Again, if it responds, if that particular channel is going to a SAS drive, then it'll know that it needs to run, SAS over this pair versus running SATA over this pair. But what's really interesting with the expanders is that the connections from the SAS expander back to the host are always SAS. So your controller that's in your the PC here, this is a SAS controller, and this cable is always running 4 lanes of SAS, even if all the drives are SATA. And that's achieved by, in the SAS world, there are several different protocols you can run as kind of the next level up after the physical protocol. One of them is called, I think it's STP, which is the SATA transport protocol. And so this controller knows how to do STP. And so when you plug in a SATA drive, this controller will recognize, oh, there's a SATA drive out there behind this SAS expander. And it will then know to use the STP protocol to encapsulate SATA commands inside of a SAS frame. So this will be a SAS frame that will go across this cable, just like it was going to a SAS drive. And the expander will see that and take off the wrapper and then transfer it over and signal it in the SATA signaling standard to the SATA drive. And so from your controller's point of view, it sees a SATA drive, it knows to encapsulate in this STP. And keep in mind, if you have both a SATA drive and a SAS drive, so some of the traffic on one of these lanes may be STP traffic, and the other traffic can be the SAS envelope standard, which is a standard that you can transfer SAS frames over a link that has multiple protocols on it. And so the best part is that this lane is always going to be SAS. And in most controllers that I've seen, the speed of this here is dictated by the controller here, meaning this will be SAS 6 gigabit. The frame is going over this here. Even if you plug in a SATA drive that is a SATA 3 gigabyte or gigabit drive. So if you plug in a SATA 3 drive, which is the old, earlier, before SATA 6, the communication between the server and the expander here is actually done with SAS 6 frames. Now, you might be excited and think, great, so I don't lose any performance. That is entirely true, because the expanders are somewhat odd in that when I first saw them many years ago, I assumed that they acted like a router, that, they sat here and a frame comes flying in and they go, oh, that's for drive number 4. Cool. I'll store it here and say, okay, got it. and then I'll figure out how to get it to drive number 4. Meanwhile, another frame may be coming back in or a frame leaving. But it turns out that the original SAS expanders are generally done in a much more circuit switched way, meaning that when a packet is coming in for, let's say this is an STP, so it's for a SATA drive that you have connected using SATA, and so your drives are over here, it effectively opens up almost like a circuit between these two. Now, it isn't a physical circuit. If you read some of the older, there's a great SAS architecture book by Mindstorm that's from like 2006. And they kind of imply in there that the expanders are literally just like circuit breakers that literally connect these lines. That isn't quite true for a couple reasons. One is that you have to unpack the STP. And the second is that generally you don't want to do renegotiate rates for this being at 3 and this being at 6. But they do operate in this manner in the sense that if it takes X amount of time for this packet to go from here through here, downgrade to 3 gigabit, and then make its way, into the drive, this lane is entirely blocked while that's happening. And so if you put a 3 gigabit SATA drive on one of these expanders, the other drives on that same, if it's an expander that doesn't have a crossbar, if they're combined together, then you are using more total time of one of these host channels in order to talk to the drive. And so it can limit your total theoretical bandwidth. I think today, though, you're probably not going to be buying SAS drives that are only 3 gigabit anyways. If you're buying a 14, 16, 18 terabyte drive, none of those are going to be 3. They'll all be 6 or 12 gigabit drives. So this is probably less of an issue. But it is good to know that from the point of view of how the controller sees it, it is able to talk to each of the drives over effectively the correct protocol. There's probably one other thing worth noting, which is that, so the connection between the JBOD and the server, I mentioned as these 4 lanes that are 6 gigabit. And if you take into account the 10 to 8 encoding, this total cable can do somewhere between 2 and 2.2 gigabytes per second. And so that's like the maximum amount you can get over that cable. And so if you think about a minute, if you have 16 hard drives in here, and if you buy a relatively new, maybe a 16 or 18 terabyte drive right now, even a SATA one, those will typically, the single drive will typically read at somewhere between 250 and 300 megabytes per second. So one drive max of about 300 megabytes a second. I think I tested the ones we're going to use, and they tested it at like 276 or 277 megabytes per second. Just pure stream rate, as fast as they're ever going to go. So what's important is that if they were really 300 megabytes per drive, and you have 16 drives, then that's 4.8 gigabytes per second if all the drives were reading at full rate. So that's cool, except of course, this interface will only do about 2.2. And so when you have 16 drives in one of these JBODs with a single 4-lane SAS, you are oversubscribed. The drives can push data faster than what the actual controller can at its maximum rate do. Now, if this was instead a SAS 3, so if it was a SAS 3 box, and this negotiated link was SAS 3, those links are 12 gigabits apiece. However, there is a catch about that. And this is an interesting kind of twist of how SAS works. If you have 4 lanes from the host to the JBOD, and they're negotiated at 12 gigabits a second, but the drives are all 6 gigabit drives, when you are talking to a single drive, it is effectively running from the host to the drive at only 6 gigabits. Now, there are some cool technologies. LSI has one for talking to SATA drives. I think it's called, not dual bank, I forgot what the name was. Yeah, I can't remember the name now. But they have a technology where if you have a 12 gig connection, you can actually have 2 SATA 6 gig connections appear. It packs them together. And so then you can really be talking to 2 SATA drives, each at 6 gig, while over one of your lanes. And so that would allow you to, instead of going from 2.2, it'd allow you to go to maybe 4.4 gigabytes per second as sort of the maximum rate. So again, there's an advantage of SAS 3 in that you have a little greater bandwidth there. But fundamentally, so it's 16 drives, you're oversubscribed. Now you might think, well, we're oversubscribed 2 to 1, but first of all, that's a pretty high number, 300. It's more likely to be 270, so this is a little lower. And in most cases, you aren't necessarily writing in a way that's streaming to all the drives perfectly simultaneously. So this oversubscription is not terrible, 16 drives to 2 lanes, but it is oversubscribed some. You are leaving some performance on the table. And keep in mind that if you're running a ZFS array, either RAID Z1 or 2 or 3, it's striping the data across all the disks. So you are genuinely writing to all of the disks at one time. So this is a legitimate concern. So a couple options. One thing is you could just get 12 disk arrays or only put 12 disks in, same thing. And for every 12 disks have a dedicated 4-channel SAS cable. Most of the adapters you buy are going to be dual anyway, so they'll have 2 basically SAS interfaces. So you could just buy 2 of these JBODs and put 12 disks in each one. That's an easy way to do it. There are some of these JBODs that have like 36 or 40 disks. And of course, at that point, you're really, really heavily oversubscribed. But there is something you should consider in terms of like, what does it mean to be oversubscribed? So if the data rate from my JBOD to my server is really limited to 2.2 gigabytes per second, that's as fast as we're ever going to get from those disks. Well, consider that this box may be sitting on your home network. And let's assume that you have a 10 gig home network. And so you have, a couple of servers over here, some boxes, maybe a Plex streamer, some things backing up, whatever it is. And they're all limited to this 10 gig connection. Well, this is 10 gigabit. So this is a little bit over 1 gigabyte per second. And so you're not serving anything outside of this box faster than 1 gigabyte per second anyways. Now, there is a little bit of multiplication here because if you're, let's say, writing in 1 gigabyte per second, remember that if you're running like RAID Z3, your data write to the disk is faster than that. If you're running mirrored, it's twice that. So having these drives on a single SAS interface, this 2.2 gigabytes per second, when your network is 1 gigabyte is actually a pretty good ratio. If you do this, and in fact, we'll actually test this later. We're going to build a box to test it. You'll find that this configuration can usually just about take care of one 1 gigabit adapter. It can actually go over it a little bit. So this is a good setup. And so if all you have is a single 10 gig network interface, sure, put on 16 disks or 36 disks or 40 disks, because you're never going to be able to push more than 1 gigabyte coming in, which is never going to be more than probably 2 to 2.5 gigabytes going out. So in that case, you can have these chassis as big as you want. The issue of the scale really comes in if you end up having, let's say you have a 40 gig interface or 2 10 gig interfaces. So now you're talking about 20 or 40 gigabit outside interface. And then you really might want more total SAS bandwidth. So something to consider when you're looking at buying these boxes. One of the things that I think is worth noting, that is something when you're buying these, especially to be like really aware of, is that if you see one of these and you see on the back that it has, these 2 SAS ports, you can generally assume that one is an in and one is an out. But there are a lot of them. The Dell EMC ones are popular, where there'll be a box and it'll have 2 little daughter cards, and each of the daughter cards has 2 ports. And so at first you might think, well, this is awesome. So this is, an in and an out, and then another in and out. And so that's awesome. Maybe it actually splits half the disks on each of them. But in most cases, particularly the EMC ones, this uses another feature of SAS, which is that on the connector up here, I mentioned that there are these pins that are on the top of the connector, and they're in the same place for SAS as they are for SATA. But on a SAS drive, there's also a little connector that has pins on the bottom. And this is a secondary set of pins that also has 2 TX and 2 RX. So it's like another whole SAS bus called a secondary bus. And the idea behind this is that in a device like this, every hard drive has a connection to each of these 2 SAS buses, usually through independent SAS expanders. And so it isn't that all the drives are, or half the drives are on one set and half on the other. They're all on both. And that only works with SAS disks. So if you buy one of these EMCs and you plug in SATA disks, the SATA disk will only appear on one of the controllers, and just use it as one marked as kind of the primary. And the idea is that you can put in a host adapter with 2 ports and plug it into each of these controllers. And if you do this, and actually you can do this in Linux. In fact, I have a box here that is set up this way. when the drives pop up, it recognizes it's the same disk with two different paths to it, and it creates this thing called multipath where the path names are labeled with empath in the name. And if you use the empath device name in the ZFS pool, then if either one of these lanes disappears because this controller blows up, this cable breaks, the HBA loses one of its ports, the drives will still work fine. The array won't even notice that the path changed from one path to the other because the drives effectively have two paths. Now, in general, especially for like SAS2, this doesn't allow you to like read from the drive twice as fast or anything. It is just a way to have the drives having two different physical paths from your controller into the drive array. And so just keep that in mind. There are chassis you can buy that do have more than one SAS controller. There are some backplanes that are like for 36 drive that split it up 18-18 between two outgoing SAS controllers. And that gives you obviously a little more total bandwidth. So if you're buying one of these, it's important to look and understand what the configuration is and what it can support. And so, yeah, so that's kind of a good description of some of the things to think about when you're buying these JBODs. So another minor thing is that if you're buying a server that has the disks built in, it's the same thing. In fact, the Supermicro ones, those servers, that backplane is the same backplane on the JBODs as it is on the servers. And so again, you have to be aware that if you buy one of those, it may be one that has 36 or 40 disks, but it may combine all of those down with expanders to just one 4-lane connector or to two 4-lane connectors, but multipaths. And so if you're buying in a machine, it's kind of good to know that if you end up needing more performance than one of these 2.2 gigabyte per second kind of 4-lane connections can give you, then you should either try to find one that really does have multiple SAS channels, or maybe get one that has SAS3, so the 12 gigabit channels. That helps a little bit. And of course, keep in mind there also are 12 gigabit drives too, so that's another speed enhancement. I think perhaps the bigger risk of all of this is if you want to do SSDs, because just a run-of-the-mill, really cheap SSD, like the cheapest ones you can buy, they're $30, that are SATA SSDs, you can buy ones that are half a terabyte, and they will almost all read at around 500 megabytes per second. Some of them read a little higher, but that's about the limit of what you'll get out of those drives with the simple SATA stuff. But imagine 16 of those in here, you'd be well over 3 times the total transfer rate of what the chassis could do. And so then you kind of start to lose a little bit of the gain of putting in all SSDs. So if you were going to do SSDs and you're going to do a lot of them, then you'd want to make sure that you're not oversubscribing your SAS channels. And that actually is one of the benefits of the chassis that we built by hand, is that those cases, they don't have any expanders at all. So you're getting every lane independent. So yeah, you have to buy a few more cards, but you really get high performance for SSD drives. So with this in mind, we're going to end this video because this kind of describes sort of the things that's going to work. And in the next video, we're going to physically build the server. We'll just put the disks in. That's pretty easy to do. And then we're going to do some testing with some different topologies. And I'll mention just really briefly that when I talk about topologies, what I'm referring to is, let's clear this, is that we are going to have, let me draw it out here. We're going to have 16 disks. Oops. I can draw correctly here. We're going to have 16 disks, and we could do it by having the 16 disks broken up into pairs of disks where each pair is a mirror. And then there's 8 of these mirror sets put together. We could also combine all 16 into one big array running what we call RAID Z1 or Z2 or Z3, or we could split it into multiple RAID Z1, 2s, or 3s. And so in the next video, we'll kind of go over the differences of these, and we'll actually try building them in that configuration and do some sort of quick testing to see how they perform in a typical JBOD environment. So that's it for now. And so we'll see you on the next video where we're going to build some cool disk arrays.